This is lesson 4 about powers of monomials. So we encountered the word monomial the other day, and we've been working with powers a little bit, and so this lesson will present some more useful information about powers. Now, to introduce this, let's consider this problem. The Bridgeport Science Department plans to purchase an aquarium. It is in the shape of a cube with a side length 2 to the 4th power inches. Use the questions to find the amount of water the aquarium will hold. So question 1, write a multiplication expression to represent the volume of the aquarium. Okay. We are told that the aquarium is shaped like a cube, and to find the volume of a cube, we can multiply the length, width, and height of that cube together, and that will tell us how much space is contained inside the three-dimensional object called a cube. Now, every side of the cube is 2 to the 4th power inches, and so that number can be used for the length and the width and the height. So here is our multiplication expression. 2 to the 4th power times 2 to the 4th power times 2 to the 4th power. This is the length, this is the width, and this is the height of the cube. If you multiply those together, that could get the volume of the cube. Now, number 2, simplify that expression. And what this is asking for is write as a single power of 2. So instead of having 2 to the 4th power, 2 to the 4th power, 2 to the 4th power, let's write the base of 2 one time only, and then find out what its exponent is. And to do this, we can use one of the laws of exponents from the previous lesson. To multiply powers with the same base, add the exponents. So 4 plus 4 plus 4 is 12. 2 to the 12th power is the volume of that cube. Question 3. Using 2 to the 4th power as the base, write the multiplication expression using an exponent. Okay? So instead of using only the number 2 as the base and then finding out an exponent, this time we're asked to use 2 to the 4th power as the base and then find out an additional exponent. So as I look at this multiplication expression, how many 2 to the 4th powers are there? Because an exponent tells you how many times something is used as the base. And I see 3 of those. And so if we write 2 to the 4th power as the base, and then put that in parentheses, then we can put an exponent of 3 outside the parentheses to indicate there are 3 2 to the 4th powers that were multiplied together up here. Okay. Number 4, explain why 2 to the 4th power to the 3rd power is equal to 2 to the 12th power. And so this question is asking us to make a connection between this expression being equal to this, and at the same time this expression being equal to this. It's asking it to explain that. Okay? And so we might say something like our solution to problem number 2 and problem number 3 both fit, and then problem number 2. It's not the only way to write this, of course, but what this is asking for is make a connection between this product, this answer, and then this way of writing the product. And these are all the same is the point. Okay. Now problem 5. Use a calculator to find the actual volume of the tank. We have all of these different expressions that represent the volume of the tank, but then as an actual number, how many cubic inches of space or of water actually fit in that aquarium? So let's get a calculator and find that out. We need to know 2 to the 12th power. And so 2 exponent 12, enter, 4,096. So there are 4,096 cubic inches of space inside this cube-shaped aquarium. Now problem 6, 1 gallon of water is equal to 231 cubic inches. Write an expression to find how many gallons of water the tank will hold if it's filled to the top. Hint, write a rational number. Recall, a rational number is a number that could be written as a ratio, one number compared to another. So what we know is that the total volume of the tank is 4,096, and then we can use a division bar or a fraction bar, you might call that, and compare that to 231 cubic inches of space in each gallon. And so what we've done here is basically created not only a rational number, but a division expression that could be used to find how many gallons of water are in that tank. And in question 7, that's what it asks us to do. How many gallons of water will the tank hold? So let's simplify this rational number. Again, on a calculator, we can find that answer pretty quickly. So we have our 4,096, which is still on the screen, and we want to divide by 231. Enter. 17.73. Now the directions say to round this to the nearest gallon, and so when we look at the next digit over to see if it's 5 or higher, the digit 7 is 5 or higher, and so we round this digit upward. We're going to call that 18 gallons. So this aquarium that the science department wants to purchase will hold 18 gallons of water. Okay, the purpose of this introduction was to get us thinking again about repeated multiplication and base numbers and exponents and various forms that you can write powers in. Okay. So let's look at the first key concept for the lesson. The key concept is called power of a power. To find the power of a power, multiply the exponents. I recall that the other day we looked at some exponent laws in which we were trying to accomplish something, and one time we added the exponents. In a different situation, we subtracted the exponents. And so power of a power is one of these exponent laws in which we're going to end up multiplying the exponents to simplify a situation. Now here's an example of what this is about. 6 to the 4th power raised to the 5th power. Here is a power, and then it's being raised to another power, and that's what power of a power means. Okay? Now 6 to the 4th power raised to the 5th power means 6 to the 4th times 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 6 to the 4th, right? That's what an exponent of 5 means, to write that out 5 times. But then we can apply the product of powers rule from the other day, which explains how to multiply when you have the same base. So all these 6's here are the same base. You can add up all the exponents, and that makes 6 to the 20th power. Now the purpose of the power of a power rule is to give us a quick way to find this result without writing all of this out. Okay? To find the power of a power, multiply the exponents. 4 times 5, that's the 20. And so we can quickly go from this form to this more simplified form by using the power of a power rule. Okay? Now there are some examples that follow that are about this. I'm going to work the first 2 for your notes and then ask that you try 3 and 4 on your own, and then the answer will be shown in the video. So question 1. Here is a power. That power is being raised to another power. And so we can apply the power of a power rule, which says to keep that base and multiply the exponents. And so that answer is 8 to the 24th power. Number 2, this will work with variables as well. Okay? We need to recognize what it is we're looking at. Is this the kind of problems from yesterday where we're repeatedly multiplying things? Is this a division problem? Or is this a power of a power? Okay, here is a power, k to the 7th power, that's a power. And then here is another power to the 2nd power. It's a power of a power. We need to recognize this when we see it. There's something with an exponent. It's going to always have parentheses around it. And then there'll be an exponent on the outside of the parentheses. That's what you need to look for to recognize a power of a power form. Okay? Now, as soon as we recognize it, we can apply the rule. You keep the base and multiply those exponents. And so the result is k to the 14th power. Okay? Please try 3 and 4 on your own, and then the answer will be there in a bit. All right, and here are the answers to number 3 and 4. Problem 3, this is a power raised to a power, and you can do that by multiplying the exponents to get 2 to the 15th power. Now problem 4, there's a power raised to a power, and then in turn that is in a group of parentheses and it's raised to another power. So this is still power to a power, but more than one time. So working from the inside out, keeping the base of 3, you can multiply those exponents together to get 3 to the 6th power, and then keep that in parentheses for now and put the exponent of 4 on the outside, and then do the power of a power law one more time. Multiply those exponents to get that final answer. All right, so that key concept was about power of a power, a way that you can quickly simplify a math expression that has a power in parentheses and then another exponent on the outside of the parentheses. Now there's another key concept in this video. This one is called power of a product. Okay, this is another one of the laws of exponents, or rules of things that you can do with exponents to simplify them. The power of a product law says to find the power of a product, find the power of each factor, and then multiply. Okay? So what does that mean? Here's an example so we kind of have a visual representation in our minds of what power of a product is even talking about. Okay? Here is a product, 3 times a squared. This is a product between the 3 and the a. Even though there is no symbol shown, that's a multiplication in there. That's called a product when you multiply things together. Okay? So inside these parentheses is a product. And this, one of the parts of that product is a power, right? A to the 2nd power, that's a power. This is called a power of a product because that product is being raised to a power. Okay. So how do you do that when you have something so complicated? Multiple things in the parentheses, possibly an exponent in the parentheses, and then on the outside of the parentheses, another exponent. How can you simplify such a complicated looking math expression? And what's being shown here is the meaning of having 3a squared raised to the 4th power. It means you have 4 of these things. And here it's written out 4 times. And then to aid in actually finding the answer, we can apply the commutative property of multiplication, which says if you have a whole bunch of things all being times together, it doesn't matter in which order you times them. And so I've separated out all the coefficient of 3 and put those first in my multiplication problem, and then separated out all of the a squareds and listed those next in the multiplication problem. So this problem here is the same math problem as this problem here. It still has all the same amount of 3's and all the same amount of a squareds, and they're still all being times together, but I've grouped the 3's together and I've grouped the a squareds together, just as a visual thing to help me get the correct answer. Okay. So I notice there are 4 3's, and that can be shown like this, 3 to the 4th power. And I see that there are 4 a squareds. That can be shown like this. And then to finish simplifying, this part here in the rule where it says and multiply, that means actually, find what are the results for these things. What is 3 to the 4th power as a number? What is a squared to the 4th power? 3 to the 4th power is the number 81. Okay? And a squared to the 4th power, applying the power of a power rule from today's video, where you multiply those exponents, is a to the 8th power. So this is the simplified version of this problem. Okay? But we don't want to take the time to write this all out like this. That takes a really long time to do what can be done very quickly by using the power of a product rule. To find the power of a product, here's how you do it. Find the power of each factor and then multiply. Okay? When I look in the parentheses, the first factor in there is 3. I want to find 3 to the 4th power. That is, I want to take the exponent outside the parentheses and assign it to that first thing in the parentheses, 3. That is, I want to take 3 and go to the 4th power. Okay. Now, what's the next factor in the parentheses after the 3? It's a squared. Okay. Then I want to take that a squared and also assign that exponent of 4 to it. So I want to take the a squared and raise to the 4th power. That's what the previous concept in the video is about, is how you do that. And you can do that by multiplying the exponents together. 2 times 4 is 8. And so the idea is we can quickly get to that answer by finding the power of each factor. That is, taking the 3 and raising to the 4th power, and then taking the a squared and raising to the 4th power. And remember, 3 to the 4th power is 81, and so you certainly can get from this to this quickly. There's a couple examples below that are about this. I'm going to try 2 of them for your notes and then ask you to try 7 and 8 on your own. Okay? So problem number 5. I have in the parentheses a product. There are 2 things multiplied together. That is a product. And that product is being raised to a power. So this fits the form power of a product. I want to find the 4th power of this product. Okay? To find the power of a product, find the power of each factor. So what is the first factor in the parentheses? It's the 4. Raise that 4 to this exponent. Now, what's the next factor in the parentheses? It's p to the 3rd power. Raise p to the 3rd power to that power. And the way that you raise p to the 3rd power to the 4th power is by multiplying the exponents, getting this. And so here is the simplified version of that problem. Problem 6, same idea. We have parentheses, and in the parentheses there are things being multiplied together. That's called a product. And that product is being raised to the 5th power. So we can simplify this by using the power of a product rule. Raise each factor to that power. So what are the factors in the parentheses? The first factor in the parentheses is -2. The second factor in the parentheses is the m to the 7th power. And the third factor in the parentheses is the n to the 6th power. Raise each of these things to the 5th power is the idea that we're working with. So let's start with -2. We want to take -2 and raise to the 5th power. Now let's move over to the m to the 7. We want to take m to the 7th power and raise to the 5th power. That's m to the 35 power. Now let's move over to the n to the 6th. Let's take n to the 6th power and raise to the 5th power. What would this exponent be? A 30. Here's the result. There is one more thing that could be done. Because -2 to the 5th power is a pretty small number, it doesn't really take a calculator to find it. We certainly could evaluate -2 to the 5th power and get that as a single number. -2 times -2 is 4, times -2 is -8, times -2 is 16, and then times -2 is -32. But the variables are still going to look the same. So here is our simplified version of this pretty complex looking math problem. And we were able to get this answer by using laws of exponents. In particular, the law of exponent that applies here is called the power of a product law, which is written up here on your note page. So please try 7 and 8 on your own by using the power of a product rule, and then the answer will be shown in a bit. Here are the answers to 7 and 8. So in problem 7, take the factor 8 and raise it to this power, so 8 to the 2nd power. And then take the factor b to the 9th, raise it to the 2nd power by multiplying the exponents to get this. 8 squared is 64, so this right here is a good form for a final simplified answer. Now in problem 8, take the first factor of -5 and raise it to this power. Then take the factor w squared and raise it to that power by multiplying the exponents. And then take the last factor z, or you could think of it as z to the 1st power to mean that there is a single z, and raise it to the 3rd power by multiplying the exponents. 1 times 3 is an exponent of 3 for z. Now, -5 to the 3rd power means -5 times -5 times -5, and that's -125. And so this right here is a good form for the final simplified version of this. So that concludes the video for this lesson. The purpose of the lesson was to provide 2 more of the exponent laws, which are rules that you can follow to work with math expressions that have exponents. In this class, and certainly in your high school classes like your algebra class, there's going to be math problems that have some fairly complicated expressions that involve exponents, and it will be possible to simplify those problems up to much smaller and easier to understand problems if you apply the laws of exponents.